Hello everyone, in this video we're going to talk about experimental chemistry and the type of questions that are usually tested in ATP or paper 4. So let's get down to business. In question number 1, they have given you some pieces of apparatus and you are being asked to name them. So what exactly is P? P is called a Liebig condenser. Please be familiarize yourself with all these apparatuses because they're going to ask these questions from you. What is Q? Q is round bottom flask. And they are pretty straightforward questions, and you can get almost 3 marks for these. And R is a filter funnel. A filter funnel. Again, in the B part, the student transfers 25 centimeter cube of ethanol into apparatus Q. This is Q, this is round bottom flask. And then it adds an oxidizing agent and assembles the apparatus as shown. Okay. So what exactly is he asking you? Name a suitable piece of apparatus to measure 25 centimeter cube of ethanol. When you see 25 centimeter cube, now it's mostly going to be pipette. And the fact that it is, we are transferring 25 centimeter cube of liquid, it means that pipette is basically used to transfer liquid from one container to another. Right? So 25 centimeter cube, if you see now, so you can simply write pipette here. Name a suitable oxidizing agent. You can use acidified potassium manganate. Acidified potassium manganate. We know the oxidizing agent in the syllabus is potassium manganate. And state the color change that would be seen with this oxidizing agent. It turns from purple to colorless. You can also write pink to colorless or purple to colorless. Suggest a reason for placing P vertically. This P apparatus, this condenser is placed vertically. Is asking why. Okay, it is placed vertically because so that it can prevent vapors from escaping. For example, vapors are going from here, right? Like this, and we are entering water in and water out. You need to understand what exactly is happening here. This is something that we call heat under reflux. This is something that is called heat under reflux. Why do we do it? There are some reactions which has to be taken place at high temperatures. But let's say A and B are reacting in this, okay, and this reaction has to be done at 300 degrees Celsius. But the boiling point of A, let's say, is 200 degrees Celsius. The problem is at 300 degrees Celsius, A will be vaporized. So what have we done? We have installed a condenser, right? So if the vapors, this A's vapor go into the go upwards, right? So condenser is going to condense the vapors and they're going to come back and drop into this overall solution, overall mixture or overall reactants. So this way A will not be lost. That's why we are adding. That's why we have installed a condenser here. So what are you going to answer here in this question? Suggest a reason for placing apparatus P vertically. It is to prevent vapors from escaping. It is to prevent volatile substances from escaping. Okay, in the C part, it says that after all the oxidizing agent reacts, apparatus Q contains a mixture of ethanol, water, and the product of the oxidation. Name the product of the oxidation. If Q had ethanol, so its oxidation would have produced ethanoic acid. We know that alcohols get oxidized to carboxylic acids. Name the process used to separate the three liquids in the apparatus Q. Whenever you're going to separate the three liquids, especially organic liquids, you're going to use fractional distillation. Okay. You can take Q from the fact that whenever you have to separate liquids, most likely it's going to be separated by fractional distillation. State why this process is suitable. You should refer to a physical property of the liquids. So, on what physical property does fractional distillation operate? That is boiling point. Okay, so we can do fractional distillation of these three liquids because all of these three have different boiling points. So you can simply write this process is suitable. Do not write two-word answers. Please make a full sentence. This process is suitable because all the liquids have different boiling points. Have different boiling points. Boiling points. Okay, in question number 2, a student uses the apparatus to make ethanoic acid from ethanol. Name apparatus A and B. It's the same thing. A is Levy condenser and B is round bottom flask. Identify two errors in the assembled apparatus shown in the diagram. What are the two errors in this apparatus? First of all, this apparatus must not be sealed. So you have to identify this that apparatus is sealed. That is the first error. This apparatus should never be sealed. Why? So that if any vapor, if there is any vapor which condenser has been unable to condense, and if it exits, okay, it has to be let go. If it is sealed, तो vapors अंदर ही build up होना शुरू हो जाएंगे, pressure अंदर ही build up होना शुरू हो जाएगा, the whole system can collapse. Okay, so apparatus must not be sealed. So the first error is that apparatus is sealed, and the second one is that that the water in and water out is labeled the wrong way. Water in has to be from here. Water in has to be from here, and water out has to be from there. You have to make sure that when you're for example, if the apparatus is this way, if the condenser is this way, right? Even then we push water in. You have to push water in. Okay, you cannot let water act under the gravity. Like you cannot push water, you cannot like put water in from here. Okay, you have to push water against the gravity so that it remains in the system for a while. Okay, similar situation is here. पानी जो है वो नीचे से इन करेंगे, अगर ऊपर से इन करेंगे तो वो फौरन ड्रेन हो जाएगा. बिल्कुल इसी तरह से अगर आपका कंडेंसर टिल्टेड है तो हम वाटर ऊपर से इन नहीं करते क्योंकि वो इमीडिएटली ड्रेन हो जाता है. ठीक है, हम नीचे से इन करेंगे वाटर. ओके, we have to make sure that water has to be pushed against the gravity so that it remains in the system for a while and it comes into contact with the condenser tube for a longer time. Okay, so the second one is that water in and water out is labeled the wrong way. Water in and out are labeled the wrong way. Okay. Okay, in the C part, the question states that why apparatus B is not heated directly using the flame of a Bunsen burner. Apparatus B had alcohol, and alcohol is flammable. Flammable substances should not be heated directly. So you will write that alcohol is flammable. Flammable means that can catch fire. And name a piece of apparatus that is used for heating without a flame. You can use an electric heater. An electric heater. Okay, heating with apparatus A in the vertical position is called heating under reflux. Describe what happens after the vapors from the apparatus B enters apparatus A. So apparatus B was round bottom flask and apparatus A was condenser. So what happens when these vapors enter the condenser? They get condensed and liquid falls back into the flask. So you will write that vapors condense and fall back into the flask. Diagrams of some of the apparatus the student uses are shown. Again, A is called a burette. You should know all these apparatuses. Apparatus B is called a measuring cylinder, and apparatus C is called a pipette. Often students confuse pipette with burette. Always remember that a burette has a tap at the bottom. A pipette never has a tap. Okay. Okay. Student wants to separate a mixture of dyes so that the dyes in the mixture can be identified. The apparatus the student uses is shown. The student also tests dyes A, B, and C. Okay. Name the process the student uses to separate the mixture of dyes. This process is known as chromatography. I hope you're familiar with it. If you're not, then watch the second video, separation techniques. The apparatus shown in the diagram is set up incorrectly. Explain why. See, this baseline has to be above the level of solvent, because the idea is that baseline would be here, somewhere here, and the solvent will travel up, and then all the dyes will be separated into their components. If you're just dipping the baseline in the solvent, that would mean all the separation would be done within the solvent. All the colors will be dissolved in the solvent. So separation would not be achieved. So you should know that the baseline must be above the level of solvent, must be above the level of solvent. Okay. Okay, apparatus is then set up correctly. The solvent travels up the paper is removed and then dried. The result is shown in the diagram. Okay. Which of the dyes A, B, C, and D are present in the mixture of dyes? So you have to see that mixture of dyes के सामने कौन सा spot आ रहे हैं. Like for example, A is present in the mixture, and C is present in the mixture, and D is not present in the mixture, and B is also present in the mixture. Okay, so you will write A, B, and C, because all A, B, and C have spots whose RF values are equal to the RF values of one of the spots in the mixture of dyes. Let's go to question number D. The student identifies the dyes in the mixture of dyes using RF values. Measure the distance between baseline and the solvent front, the baseline and the position of A. Calculate the RF value of A. He has just split it into multiple steps. If he just asks you to calculate the RF value of A, you should know that RF value is equal to distance traveled by dye, over distance traveled by solvent. Okay, how would you measure the distance traveled by dye? For example, if you want to measure the RF value of A, so A is going to be the dye. So you will take the distance from the baseline to the spot of A, from here to here. Now, I cannot measure it right on scale. I'm just giving you a basic idea how to do it. Just make sure that you take the distance from the baseline to the center of the spot. Okay, to the center of the spot. You will use a scale to do that. And then for the distance traveled by the solvent, you will take the distance from the baseline to the solvent front, from here to here. For example, if he had given you a solvent level as well, often students make a mistake that solvent level is here, so they measure the distance from the solvent level. No, you will always measure the distance from the baseline while calculating the RF values. Okay, so okay, once you do it, this would come as 6 centimeter. This would come at around 1.5 centimeters, and you will just plug it in. 1.5 over 6 would be 0.25. This would be your answer. Okay, so we have another question related to chromatography. A molecule contains 4 amino acid units. These amino acid units are linked in the same way as in a protein. A sample of this molecule is hydrolyzed. The resulting solution is spotted on the chromatograph paper. The point is that the amino acid solution is यहाँ पे spot लगा दिया उसका. The paper is placed into a suitable solvent. The diagram of a final chromatogram is shown. Okay, this is your sample spot. This is your initial line. Initial line is the same thing as baseline or origin line. Suggest why the initial line is drawn in pencil and not ink. Obviously, because ink will also spread now. So we use pencil so that it does not. A pencil do not have any dyes as such now, so it will not interact with the dyes in the spot. So we do not use ink. Why? Because ink would dissolve as well. Because ink would dissolve. Okay. So draw a line on the diagram of the chromatogram to show the depth of the solvent into which the paper is placed. So you just have to make sure that the initial line is above the level of solvent. The baseline has to be above the level of solvent. So draw it anywhere below the line, okay, like this. Suggest how chromatogram needs to be treated to make the spots visible. See, amino acids are invisible. Sorry, amino acids are colorless substances, and we often when we discuss chromatography, we say that chromatography is used to separate colored substances, but in some cases it can also be used to separate colorless substances like amino acids, and for that we use a substance called a locating agent. We spray the chromatogram with a substance called a locating agent, and these invisible spots become visible. So how the chromatogram needs to be treated to make the spots visible? We actually use a locating agent. Spray, actually just write the full line, that spray the chromatogram with locating agent. Try to write full lines, okay? Not try, actually write full lines. Okay, what effect does hydrolysis have on the sample of the molecule? So a molecule had what? It had amino acids, right? So अगर हाइड्रोलिसिस हुई है तो प्रोटीन्स की हाइड्रोलिसिस होती है ना बेसिकली. तो प्रोटीन्स की हाइड्रोलिसिस. Now you don't have, actually, as far as O level students are concerned, you guys, the hydrolysis of polymers has been subtracted out of the syllabus. So you don't have to memorize it, but you need to know that when proteins are hydrolyzed, amino acids are produced. So what effect does hydrolysis have on the sample of the molecule? Amino acids are produced. Okay, right? Produces free amino acids. Produces free amino acids. Suggests the reason why only 3 spots are detected. If there are 3 spots, it means there are 3 substances. There are 3 dyes. So यहाँ पे amino acids हैं, so you can write why are there 3 spots? Because there are 3 amino acids. So you will write only 3 amino acids are present in the sample. 3 amino acids are present in the sample. So you need to understand that if in the chromatogram the number of spots is directly proportional to the number of substances in the sample. Okay, so if there is only one spot, that means the substance is pure. It only has one substance. Okay. Okay, so RF values of some amino acids in the solvent used for this experiment are shown. So state how an RF value is calculated. You will write that RF value is equal to distance traveled by dye over distance traveled by solvent. We did this in the last question. Okay, state which one of the amino acids is present on the chromatogram. They are given the RF values of all these amino acids. Now what you need to do, you will go back to the diagram. Okay, you can just pause the video and go back to the diagram and calculate the RF values of each of these. Okay, so if there are 3 spots, you have to calculate the RF values of all of 3, and then you will have to compare that if any of these RF values, compare with the RF values of these substances. If any of these compare, it means that, for example, if there is an RF value, if there is a dye whose RF value is 0.38, it means that the mixture had alanine. If an RF value, if a substance has an RF value of 0.73, it means the substance had leucine. Okay, that's how you will do it. I cannot do it digitally because you need a scale and all of that. So I would recommend you guys to do it yourself. So your answer should include measurements from the diagram and a calculation to justify your decision. So basically, you will have to do all the calculations. Again, you will get to know that there is one substance, phenylalanine, is present. So in this, phenylalanine is present. Okay, what you can do is you can freeze the screen and like open it on a bigger screen and freeze it, and then use a scale to measure it. And you will see that there will be a spot whose RF value will be equal to 0.68. And from here you can see that phenylalanine will be present. Okay, so the three gases have the properties shown in the table. The density is shown, their solubility is shown, their appearance is shown. And this is the downward delivery method, this is the upward delivery, and this is collection over water. So which apparatus X, Y, or Z is most suitable to collect each gas? Gas A. Let's look at the properties of gas A. Gas A is more dense than air. If it's more dense than air, obviously it will go downwards, downward delivery. And it is soluble in water, so you cannot use this, right? So you'll have to pick X here. And for gas B is less dense than air, then obviously you'll have to do upward delivery method. Again, it is soluble in water, you cannot use water. So this would be Y. And if we look at the gas C here, so obviously the apparatus Z would be used to collect gas C. You cannot use Y to collect gas C because gas C is more dense than air, and this is upward delivery. This is used for gases which are lighter than air. And you cannot use the apparatus X to collect gas C, even though the density of gas C is more dense than air, so you can collect it by downward delivery. But the problem with this is that the gas is colorless, so you will not know when this jar will be full because it is colorless. So that's why we use the apparatus Z for gas C. Okay. So that's what you will write here, that gas C can be collected using apparatus Z. State why apparatus Z is more suitable than apparatus Y to collect gas C, because like I told you, apparatus Y का upward delivery वाला, ठीक है? Because Y is used for gases lighter than air. Okay. And state why apparatus Z is more suitable than X. X was downward delivery wala. Even though it can be collected, but you will not know when the jar is full because it's colorless. So you have to be looking here because if using X, it is not possible to tell. It is not possible to tell that when the gas jar is full. When the gas jar is full. So sorry. So from here you actually got to know the name of another apparatus, that is a gas jar. These apparatuses are known as gas jars. Okay. They can ask you to label this as well. Okay. Name apparatus A and B. That is simple. If you know the apparatuses, then it gets really simple. So apparatus A and B. What is A? A is called a crucible, and B is called a tripod stand. So a sample of ethanoic acid can be prepared in the apparatus shown. Name apparatus C. I have done this like million of times. What is the purpose of apparatus C? We have done that as well. But you will not write just to condense. Just be a bit more precise. Now that you know you have ethanol and potassium manganate, ethanol will be vaporized first. So you can simply write to condense. Volatile. अगर आपको नहीं पता इसका सब्सटेंस कौन सा, तो ये लिख लेगा, to condense volatile substances and return them to the flask flask. After heating the mixture in the flask for some time, all the ethanol will be oxidized to ethanoic acid, so the reaction is complete. So draw a diagram to show how the apparatus may be adapted to allow the ethanoic acid to be distilled from the resulting mixture in the flask. You should add any further apparatus to your diagram to enable the distillation to take place. So basically our apparatus was, there was a round bottom flask which was attached to a condenser. Now there's no need for condenser, the vertical condenser here, because the reaction is complete. All you need to do is to separate ethanol. So you'll basically be drawing a simple distillation apparatus. Okay, a simple distillation apparatus, that's what you will be drawing. So let's plug in the thermometer here, and यहाँ से ट्यूब निकालने हैं आप, condenser tube. Please ignore mine here. I just need to understand what you guys need to draw and label. Okay, so water in, or to be more precise, cold water in and hot water out. Label that. Okay, and then label the thermometer. Please draw a diagram that looks much better than this. Okay, and then that's a very wide mouth conical flask. You have to draw a conical flask. Okay, make sure that the tube mouth is at least inside the opening of the conical flask, but should be always be kept open. Why? Because in case if there are any vapors enter this, if you seal it, then अगर यहाँ पे कुछ ऐसे वेपर्स आ गए हैं जो कंडेंस नहीं हुए, तो पूरा रिवर्स प्रेशर जाएगा and the whole system can collapse. Okay, so it has to be kept open. So these will be your 4 marks. So the boiling point of ethanoic acid is 118 degrees Celsius. Suggest which compound in the final reaction mixture will be the first to distill over and the temperature at which it distills. Okay, so ethanoic acid is 118. The other substance in it is obviously water, because alcohol ethanoic acid में convert होगा तो solution में water ही है ना. So the compound which will distill first will be water. Why? Because it has a boiling point of 100 degrees Celsius. At what temperature? 100 degrees Celsius. What does the student observe when a small volume of ethanoic acid is added to a test tube containing aqueous sodium carbonate? It's simple now. When acids react with metal carbonates, carbon dioxide released. So what would you observe? You observe fizzing, bubbling, or effervescence. Effervescence. So a student is asked to produce a dry sample of hydrogen by passing it through a drying agent. You should know the drying agent, a very famous drying agent is sulfuric acid. Okay. The direction of the flow of the gas through the apparatus is shown by arrows. Which apparatus X, Y, or Z should be used? Okay, it goes in. The thing is that the tube has to be dipped inside the liquid. Na? The gas has to be bubbled through the drying agent. If you want to pass a gas through a liquid, you have to make sure that the gas is bubbled through it. Like the gas goes inside the liquid. You cannot keep it at the bottom. You cannot keep it at the top here. You have to keep it dipped. Okay, so this is correct. Now, why is this cannot be the option? Because both of the things are dipped. Because once the gas is dry, if it's insoluble, it will collect it over here. And if you have dipped the delivery tube inside the liquid, then there's no in for all these vapors. They cannot go inside the tube again.